Hello everybody, this is Mr. McNair, and this is going to be a short review video on solving linear systems with word problems. Now, say you go to the store and find that Reese's cost 50 cents each. If you buy one pack of Reese's, how much would that cost you? Yeah, 50 cents. Now, let's change it up a little bit. Let's say instead of buying just one pack, you buy 3 packs. How much would that cost you? $1.50. Good. Now, how do we find that out? We take the cost of the Reese's, which is 50 cents, and we multiply that by the number of Reese's that you buy. Okay? And if I let R equal the number of Reese's. So this expression here would allow us to find out how much we spend total no matter how many Reese's we buy. Now, let's apply that to a linear system word problem. Your friend goes to the store and buys a total of 7 candy bars, some Reese's and some Snickers. Reese's are 50 cents and Snickers are 75 cents. If she spent a total of $4, how many of each type did she buy? Now, to be completely honest, there's a couple ways that you could do this problem. One of the more, I would say, non-mathematical ways would be kind of trial and error. You can make a table of the values and kind of just keep trying them until you find out one that works. Now, you know that we have, according to the problem, a total of 7 candy bars. So if your friend buys 1 Reese's, how many Snickers did she have to buy? 6, because we bought a total of 7. Now, Reese's are 50 cents each, and Snickers are 75 cents each. That total cost would come up to $5. And you could keep, and we know that this couldn't be the right answer because we didn't spend $5. We spent $4. So it couldn't have been that combination. And then we could keep on trying one. If we had 2 Reese's, we would have had to have 5 Snickers, and that cost would have came out to be $4.75. Still not $4. 3 Reese's and 4 Snickers didn't work. 4 Reese's and 3 Snickers didn't work. 5 Reese's and 2 Snickers. That finally came out to the $4 that we needed. Now, this process can be quite tedious, especially if we're dealing with really large numbers. Let's say instead of your friend going to the store to buy candy bars, it was a company. All right, and they were buying 1,000. You wouldn't want to have to make a chart to find out how many of each they bought. So another way to do that is to make a system of equations. Let's say we have the number of Reese's equals R, and the number of Snickers equals S. We know that we bought a total of 7 candy bars, so the first equation we could write is R plus S equals 7. Another equation we could write deals with the cost. The cost for each Reese, like we were dealing with before, is 50 cents for each Reese. So the cost for the Reese's are 50 cents per Reese cup. Plus, what would be the cost for the Snickers? 0.75 for each Snicker. And that equals a total of our total cost, which was $4. Now we have a system of equations. And you're going to go through and solve it by the elimination method. Here, are the variables lined up? Yes. R's under R's, S's under S's, equal signs lined up. If you add down, does anything automatically eliminate? No. So you need to make something eliminate. What cancels with a 0.50R? Yeah, a negative 0.50R. So we can multiply the top equation through by negative 0.5. And remember, when you multiply an equation, you have to multiply everything in that equation. So our new top equation would be negative 0.5R minus 0.5S equals negative 3.5. Bottom equation is going to stay the same. All right. Now something will eliminate. Let's go ahead and add down. The negative 0.5R and the positive 0.5R cancel, leaving you with 0.25S on the left equals 0.5 on the right. How do you solve for S from there? Divide by 0.25 on both sides. And you get S, the number of Snickers, equals 2. Now, at the beginning we said that the total number of candy bars was 7. And if you had 2 of them Snickers, the rest of them had to be Reese's, so that obviously means it's 5. Now, if you didn't know that, you could have taken your original equation, r plus s, and we know s is 2, equals 7. All right, we just, instead of s, we put in 2. Subtract 2 from both sides. We either got r equals 5. So, once again, 5 Reese's, 2 Snickers. Alright, here's another problem. Veronica has been saving dimes and quarters. She has 94 coins in all, and the total value is $19.30. How many dimes and how many quarters does she have? Well, if I let D equal dimes, the number of dimes I should say, and Q equals the number of quarters, I know the number of dimes plus the number of quarters has to equal 94 because the problem said we had 94 coins. Now, the other part of the problem has to deal with the total value, which is $19.30. How much is the value of each dime? Well, dimes are 10 cents. Plus, how much is the value of each quarter? Quarters are 25 cents. And what's our total value? $19.30. Are the variables lined up here? Yes, D's, Q's, equal sign. If you add down, does anything automatically eliminate? No. Well, what cancels with a 0.10D? Yeah, a negative 0.10D. So let's multiply through by negative 0.10 or negative 10 cents. So remember, we're going to multiply through to everything. So the new top equation would be negative 0.1D minus 0.1Q equals negative 9.4. Bottom equation, I'm going to keep it the same. All right, now we're going to go ahead and just add down. So when we add down, the D's cancel out. Negative 0.1Q plus 0.25Q is 0.15Q. And negative 9.4 plus 19.3 is 9.9. Now we'll solve for Q by getting Q by itself. Divide by 0.15 on both sides. And we find that Q equals 66. So we have a total of 66 quarters. Now again, we said the number of dimes plus the number of quarters was 94. So we still don't know what the number of dimes are. But we know that there were 66 quarters. And there's a total of 94 coins. So we can solve this equation to find D. So D equals 94 minus 66. That is 28. So we had a total of 28 dimes and 66 quarters. Okay? Great. Let's try another one. Mrs. Gonzalez bought centerpieces to put on each table at the graduation party. She spent $31.50. There are 8 tables, each requiring either candles or vase. A candle or a vase, excuse me. Candles cost $3 and vases cost $4.25. How many of each type did she buy? Once again, I'm going to let C equal candles. I'm going to let V equal the vase or vases. So the total number of centerpieces that we had is 8. So the number of candles plus the number of vases had to equal 8. Now the cost for each candle is $3. So it's $3 per candle plus is $4.25 per each vase. And the total cost or the total spent was $31.50. Now here, are the variables lined up? Yes. If you add down, does anything automatically eliminate? No. What cancels with a 3C? A negative 3C. So we would need to multiply the top equation through by negative 3. You could have also multiplied through by negative 4.25 if you wanted to cancel out the V's. New top equation will be negative 3C minus 3V equals negative 24. Bottom equation is going to stay the same. 3c plus 4.25v equals 3150. Now we'll go ahead and just add down. So when you add down, the c's cancel out. Negative 3 plus 4.25 is 1.25, so that's going to be 1.25v. And then negative 24 plus 31.5 is 7.5. We'll solve for v by dividing by 1.25 on both sides. And 7.5 divided by 1.25 is 6. So v equals 6. Once again, at the beginning we said that there's a total of 8 items, 8 centerpieces. And we don't know what the number of candles are yet, but we do know that there's 6 vases. So we can subtract 6 from both sides and find that the number of candles equals 2. Please make sure that your answers make logical sense at the end. You know that you can't buy part of a candle, so 2.5 candles wouldn't work. You know that you couldn't buy negative candles. You can't go to a store and put candles on the shelf. All right, so negative answers won't work also. Last one. This one's a little bit different. You're planning a birthday party for your 8-year-old cousin. You have the party at a pizza place for $8 per person plus $30 for favors and a small cake, or at a taco place for $12 per person plus $14 for a large cake. How many children would you have to invite to the party for the cost to be the same for both places? All right, so here we're talking about a pizza place and we're talking about a taco place. Now, the expression that deals with the pizza place is $8 per person. So that would be 8 per person, so 8x, plus a one-time fee of $30. The taco place is different. Here, the taco place is $12 per person, plus a one-time fee of $14. And we want to know, when does the pizza place equal the taco place? So this is just a simple linear equation where you could just get the variables on the same side. So if I wanted to move this 8x over here, I could do that by subtracting 8x from both sides. So those cancel out, giving you 30 equals 4x plus 14. Then to solve for x, we would subtract 14 from both sides. So we get 16 equals 4x. And then divide by 4 on both sides. And we will get x equals 4. So that answers our question. How many children would you have to invite to the party for the cost to be the same? It would be 4. All right. Here, 8 times 4, that's 32. 32 plus 30 is 62. So it would be $62 at the pizza place if you invited 4 students or 4 children. And 12 times 4 is 48. 48 plus 14 is also 62. So it would be $62 at the taco place if you invited 4 students. All right, great. I hope that this lesson helped, and I hope that you have a great day.